In this lesson, you will learn to add and subtract fractions, but now in the context of algebra. So before I get into the algebra portion, let me do a brief review of how to add and subtract fractions with just numbers. So here we have 4/7 plus 3/7 minus 1/7. Now if the denominator is the same, I can just add and subtract the numerators accordingly. So I can take 4 plus 3 minus 1 to get 6 over 7, and that is my solution. But if the denominator is not the same, say we had 1/4 plus 2/3, I need to find a common denominator first. So to do that, I need to find the least common multiple of 4 and 3, which is going to be 12. So I find the least common multiple, or least common denominator, same thing, and it's going to be 12. So I need to convert 1/4 and 2/3 both into something over 12. Well, what is it going to be? Well, to get from the 4 to 12, I had to multiply by 3. So therefore, I multiply the numerator 1 by 3 as well, to get 3 over 12. And over here, to get from 2/3 to something over 12, I am going from 3 to 12, and to do that I multiply by 4. So the numerator I also multiply by 4. So I now have 2 times 4, which gives me 8. So I have 3 twelfths plus 8 twelfths, which would then combine to give me 11 over 12. And that is my solution. So make sure you know how to add and subtract fractions with just regular numbers, because now in the next part of the lesson, we will be throwing in variables. So the first type of question will involve variables in the numerator. So for example, we have x plus 4 over 5 minus 2x plus 1 over 10. Now for this one, to combine, we still need to have a common denominator. So our denominators are 5 and 10. So we need to find the least common denominator of 5 and 10. Well, remember how to do this. Okay, we have a 5, and you factor it down if necessary, which this one's already factored. And then the 10, you factor down to get 2 times 5. And for the least common multiple, or least common denominator, I need to see which factors are represented. So we have 5s and we have 2s. Which one has the most 5s? Well, it's a tie for the 5s, so it doesn't matter which one I take. So we'll take this one over here. So we take 1, 5, and then we ask which one has the most 2s. Well, this one has the most 2s, so we take 1, 2. So I take 5 times 2, which gives me a 10. Okay, so your least common denominator will be 10. So now I need to convert only this first fraction into something over 10. The second fraction is already over 10, so no need to deal with the second fraction. But the first fraction, it needs to be something over 10. Well, how do we get from 5 to 10? Well, we multiply by 2. So the numerator, we also multiply by 2 to get 2 times x plus 4. And that's what we see down here on this next step. So now we have a common denominator. We can distribute the 2 times x and 2 times 4 to get 2x plus 8. And then when I subtract, I am subtracting the entire quantity of 2x plus 8 minus the entire quantity of 2x plus 1. So what I have is 2x plus 8 minus parentheses 2x plus 1. And be careful, because this parentheses will make a difference. If you don't subtract this whole quantity, you will get the wrong answer. So now from here, when I subtract, I'm subtracting all of the 2x and all of the 1. So I'm basically distributing the negative 1 to get negative 2x, and then negative 1 times 1 to get negative 1. So now I can combine like terms. 2x minus 2x will cancel to give me 0. And then 8 minus 1 will give me a 7. So my solution will be 7 over 10. So that is when the variables are in the numerator. Now the question is, what do we do if there are variables in the denominator? So for example, 1 over 4a to the third minus 2 over 3ab plus 3 over 8b squared. Well, same concept. I need to find the least common denominator, or least common multiple, of 4a to the third, 3ab, and 8b squared. So looking at the numbers first, the 4, the 3, and the 8, the least common multiple of 4, 3, and 8, we could go through and take 4, break it down to get 2 times 2. 3 doesn't break down. The 8 would be 3 2s. And then we see which factors are represented. We have 2s and 3s. This one has the most 2s, so we take all of these 2s. This one has the most 3s, so we take all of its 3s and combine them all together to get 2 times 2 times 2 times 8, which gives me 24. So that's 24 for the number. And then the variables do the same thing. This one has the most a's, so we take all 3 of the a's. And then this one has the most b's, so we take all of the b's. So your least common denominator would be 24a cubed b squared. Okay, by the way, the 24 we could find by just listing out the multiples of 4, 3, and 8. 4 would be 4, 8, 12, 16, 20, 24, etc. 3, we keep going to get 3, 6, 9, 12, 15, 18, 21, and finally we'll get 24. The 8, we get 8, 16, then 24. So we could see it that way as well by listing them out. But either way, we get 24a cubed b squared. So from here, I need to now create each of these fractions with that least common denominator. So for the first fraction, we'll have something over 24a cubed b squared. So for the first fraction, how do we get from 4 to 6, or 4 to 24? Well, we multiply by 6. So the numerator we need to multiply by 6 as well. And then to get from a cubed to a cubed, nothing changes, but we also have a b squared in here that was not in the original fraction. So we need to multiply by a 6 and a b squared. Okay, in the second fraction, we need the same denominator of 24a cubed b squared. And to get from 3 to 24, I need to multiply by 8. So the 2 I need to multiply by 8 as well. And then to get from a to a cubed, I need to multiply by an a squared. And to get from a b to a b squared, I multiply by a b. And then the last fraction, I also need that common denominator. And to get from 8 to 24, I need to multiply by 3. So I need to multiply the numerator by 3 as well. To get from this to a cubed b squared, notice there's an a cubed that was not in the original fraction. So I need to multiply by an a cubed up here as well. And the b squared is in the original fraction and in this new fraction, so no need to multiply by anything with b. So I'm going to have these fractions now. And that's what you see here in this next step. So now we have a common denominator. I can then combine these fractions by subtracting and adding as necessary. So here we see 1 6b squared, then minus 2 times 8a squared b, plus 3 times 3a cubed, all for the numerator. And then from here I can multiply negative 2 times 8 to get negative 16 a squared b, and then 3 times a 3 to get 9 a cubed. So now we have added and subtracted. We've combined into one fraction. So this here would be your solution. So now we have learned how to add and subtract when there's variables in the numerator. We've learned how to do it with variables in the denominator. And the last part of the lesson is we'll learn how to add and subtract when there are polynomials in the denominator. Now before we get to that part, we need to discuss how do we find the least common denominator of a polynomial. Well, if you have the least common multiple of a polynomial, say you have these two expressions. x times x minus 1 cubed times x plus 4, and x cubed x minus 1 times x plus 4. The process is the same as with numbers and with just variables, where we see what factors do we have represented. Well, we have x's, we have x minus 1's, and we have x plus 4's. And the question is, how many of each do we take? Well, once again, we see which one has the most. So over here on the left, there's only one x. Over here, there's 3 x's. So we take the one with the most, which are all of these 3 x's. So we take x cubed for the x portion. And then we see which one has the most x minus 1's. Well, over here has the most x minus 1's with 3 of them. So we take all 3 of those x minus 1's. And then the x plus 4's, we see which one has the most. And in this case, it is a tie. So it does not matter which one we take. We're just taking one of them. So we have x cubed times x minus 1 cubed times x plus 4. And that would be your least common multiple. Now the question is, what if it's not factored already? So what if you had something like this? X squared minus 4x plus 4 and x squared minus 3x plus 2. Now if it's not factored already, we need to factor first and then find the least common multiple. So right here, x squared minus 4x plus 4, I can factor that. And by the way, if you forget how to do this, maybe brush up on a previous lesson. But when you factor, you get x minus 2 times x minus 2. This other one, when you factor, you get x minus 2 times x minus 1. So once you factor, then we can find the least common multiple. So we see what factors do we have represented. Well, we have x minus 2's and we have x minus 1's. Well, how many of each do we take? Well, this one over here has the most, so we take all of its x minus 2's. And then x minus 1's, this one has the most, so we take all of its x minus 1's. So what we have is going to be x minus 2 times x minus 2 times x minus 1. And you could write that as x minus 2 squared times x minus 1. So that is how you find the least common multiple with polynomials. Factor if needed, and then once everything is being multiplied together, see which one has the most, just like we did with numbers and with just variables. So now combining that with polynomials in the denominator. Let's say we had x over x squared minus 1 minus 4 over x minus 1. So we need to find the least common denominator. Well, to do that, I need to first factor this x squared minus 1. So when I factor x squared minus 1, it is a difference of squares, so I have x minus 1 times x plus 1. So now I ask myself, what factors do we have represented? We have x minus 1's and x plus 1's. So which one has the most x minus 1's? Well, it's a tie, so it does not matter which one we take, but it's a tie with 1, so we take 1. Then x plus 1's, which one has the most? Well, this one over here has the most with 1, so we take just 1 x plus 1. So my least common denominator would be x minus 1 times x plus 1. So now I need to write both of these fractions with that new denominator. Well, the first fraction is good. We have x over x minus 1 times x plus 1. But the second fraction we need to change. So it's changing from just an x minus 1 to now x minus 1 times x plus 1. Well, the question is, how do we get from x minus 1 to x minus 1 times x plus 1? What is different? Well, we see that the new fraction now has x plus 1. So because I multiplied the denominator by the x plus 1, I need to multiply the numerator 4 by x plus 1 as well. So now what I have is going to be x over x minus 1 x plus 1 minus 4 times x plus 1 over x minus 1 times x plus 1. And then from here, I can combine by subtracting. So I have x over x minus 1, x plus 1. And then I subtract that 4x, 4 times x plus 1. So So all I want to do now is distribute and simplify if needed in the numerator. Negative 4 times x, I would give you negative 4x. Negative 4 times 1 gives me negative 4. And x minus 4x would give me a negative 3x. So my final solution would be negative 3x minus 4 times x minus 1 times x plus 1. Let me give you one last example. Here we need to find a common denominator. Well, to do that, I need to factor the denominators first. So don't forget how to factor. But when I factor this denominator, x squared plus x minus 6, I'm going to get x plus 3 times x minus 2. This other one, when I factor, I'll get x minus 2 times x minus 1. So from here, the question is, what is the least common denominator? Well, we see what factors we have represented. We have x minus 1s, x minus 2s, and x plus 3s. And the question next would be, how many of each do we take? So which one has the most x plus 3s? Well, this one has the most, so we take 1. Which one has the most x minus 2s? Well, that one's a tie. Doesn't matter which one I take. We'll take this one over here. We're just going to take 1. And then x minus 1s, which one has the most? Well, this one has the most with 1, so we take 1. So my least common denominator would be x plus 3 times x minus 2 times x minus 1. So my new fraction will be something with that new denominator. So I'm going to write that for both of these. And then minus. And then the question is going to be now, how do we get from your original fraction to this new fraction? Well, for the first fraction, what is different from this denominator to the new denominator? Well, the difference is we now have an x minus 1. So we need, for the numerator as well, to multiply by x minus 1. And the same thing for the other fraction. What's different between the original fraction and the new fraction? Well, what's different is we now have an x plus 3. So because there's an x plus 3 now, we need to multiply the numerator as well by an x plus 3. So now I can combine into one fraction. They have a common denominator of x plus 3 times x minus 2 times x minus 1. I can combine by subtracting the numerators. So we have 3 times x minus 1 minus this 4 times x plus 3. So then we want to distribute the 3 and the negative 4 to get 3x minus 3. Negative 4 will give me negative 4x. Negative 4 times 3 gives you negative 12. Then over x plus 3, x minus 2, x minus 1. And then 3x minus 4x will give me a negative x. Negative 3 minus 12 gives you negative 15. So my final solution will be negative x minus 15 over x plus 3 times x minus 2 times x minus 1. And that concludes our lesson for today. We will see you next time.